Hi, this is Core. Today I'm going to take you through to the data test, the physics data test. Let's first look at the data set one. There are two bars, then there's a distance between the vertical two bars. One of the bar is placed on a mass balance. The other one is holding in the air by retort stand. So in this way, the top bar actually is not placed on the mass balance because of magnetic force in the mag bar. The top bar will apply magnetic force to the bottom bar, and therefore influence the reading of the mass balance. And they have done a list of experiments, and then they show the results in this uh, table. The first column is the distance r, and second one force. And the last column is average force. For the first one, they have done three trials: trial 1, 2, and 3. And they change the distance. And first, the distance is 0.01 meter, and then they gradually increased it to 0.5 meter. And then they um, they obtained the force. They observed that the force become smaller. And why does the force become smaller? And how did they obtain this force? Mm, from reading here, there's Newton, force Newton from the mass balance. Does this force Newton the same as the reading here? Both of them have three decimal places. Looks like they may be the same. And as the distance r increases, and the force between the two magnets will reduce. Therefore, this force will reduce as well. Okay, yeah, probably it's possible to obtain this force from the reading there. Now let's look at the questions. How they obtain this force probably doesn't matter. It's not a task for our data test. The goal of data test is answer the questions. Now let's look at the question, and we will be marked by the way that we answer these questions. The first question, calculate the average force N for the distance r equals 0.4 meter. We can have a look here. When r equals 0.4, and the average force is not given. So for this first question, we will ask to find out what is average force there. What we need to do is just adding all the three forces together, like say average force, average force equals adding all the three forces together divided by 3. So it's 0.6 plus 0.6 plus 0.062. Oh, it's 0.06. And then what should we have? And we will have 0.61. 0.061, because you can see that we are only going to distribute the last this these two into the other two components. So it is going to become 0. This 2 is going to become 0.6. And then when we do the rounding, it becomes 0.0. It becomes 1. So remember the unit in Newton, it has been given to us here. So what we need to do, this is a 2 marks question. And then first we should say that every force equals this. And then lastly, we should put our answer here. Here we should give the unit as well. And then we also should put our answer here, 0.061. Okay, next question. Determine the absolute uncertainty of the mean for the force F between the magnets when separated by a distance r equals 0.4 meter using the formula plus minus x max minus x minimum over 2. Absolute uncertainty of the mean for the force. We have found the mean, which is 0.062. And now we need to determine the uncertainty. The uncertainty from this graph, like it is given that we obtain these results, which has an error 0.001 Newton. And then to obtain the uncertainty here, let's say I use x maximum minus x minimum and being the uncertainty. Yeah, okay. If we use this formula, let's say the x maximum there is 0.06, 0. If this one gives us the uncertainty 0.062 minus 0.06. Remember that I remember these two numbers from the table above and then divided by 2. And the answer would be plus minus 0.001 Newton. Would this be right? Or is this the right way to do it? I may think differently, but yeah, this is the way that we are supposed to do according to the QCAA's requirement. Okay, now that's for this question, and let's keep on moving. Okay, by the way, what I would think it would be this to find an uncertainty, we need to consider the uncertainty of the and each values. For example, let's say 0.062, and then if we use this expression, it should be plus minus 0.01, and then minus 0.06, and then plus minus 0.001 over 2. And then the results would be probably 0.002 instead of 1. I'm also kind of in doubt of the formula, but nevertheless, for high school, it's probably it's good enough. Just use the method given by this formula. Substitute the x max as the number given there, and the x minimum as the number given. Yeah. Okay, let's keep on moving. Question 3: identify the relationship between R and the force F exerted on the bar, and use the evidence from table 1 display. Identify the relationship between R and two magnets. Excellent. So it's as R increases, as R increases, and F decreases, but how much F does F decreases? Let's have a look. And from 0.1, it's like it decreases F decreases more dramatically, and then it's like F square is in the reverse linear relationship with R. So here for this question, I would say F decreases decreases F square is in times R is a constant. Or like we can say F uh, or like there are many other ways to represent this relationship. As I said, F square is inversely proportional to uh, R. We can say that as well in words. Also, we can say we can use mathematical language to represent F square is inversely proportional to R. So F squared is proportional to 1 over R. That. And we can use either of this method to represent, let's say, call this. This part is kind of reasoning, and this is this part gives more detail, and this part it includes two ways of representation, and then we can use either of these two ways of representation to represent the results. Predict the magnitude of force between the two magnets when they are 0.4 meter apart. Show you are working. So from the table we have, let's say we have a 0.4 meter apart. Remember when uh, distance increase doubles, and then the force will be reduced by 4 times. So we can say, and we know this is 0.061. So we can say, oh, here is two marks question, and yeah, okay, the math when R equals 0.04, and the average force, the average force is 0.061 Newton, and as R doubles, the force will decrease by time 4 by 4 times. So it's 0.061 divided by 4. It is 0.015. Remember the uncertainty? Uncertainty is 0.001. So probably I'll just do put uncertainty here. 0.001 Newton. But why the uncertainty is still 0.01? You may ask the question here because yeah, we have uncertainty 0.01, 0.001 here, and this 0.001 divided by 4, it should be much smaller than that value. While if we obtain uncertainty from this one, yes, this makes sense. The argument makes sense. But consider the reality if we do the experiment. And okay, what should I say is that this is just expectation. This is not from the experiment. What we are doing here, this canal is we are expecting, we are predicting the value at that point by using the previous experimental data. So the error in the predicting may be much larger than the reality. So the error here just give us a little bit of sense. It doesn't mean much. It's not as what it doesn't mean the same as what we had before. It's not from the experiments. So I may not even include that error there because it's a expecting, it's a predicted value. Yeah, I just say it's 0.05. And lastly, you say the predicted magnetic force between the magnets when they are 0.8 meter apart is 0.015 Newton. Okay. That two is a dot from a projectile motion, and the horizontal axis shows us the projected angle. The vertical axis shows us the horizontal displacement. And this is not a trace of the object in the air. In that case, the horizontal axis would be horizontal position, and the vertical axis would be the vertical position. While here is the relationship between the horizontal displacement and the projected angle, so it's different. And let's look at this question. An experiment was conducted to address the following research question. What is the relationship between the projected angle of a golf ball and its horizontal displacement range when launched from ground level with a constant initial velocity of 15 meters per second? The relationship between the projectile motion is horizontal when launched from ground level with a constant initial velocity. Ground level. So this ground level, okay, yeah, with a constant initial velocity of 15 meters per second. The experiment was collected and processed and is represented in graph 1. Identify the two projected angles that produce a horizontal displacement of 20 meter and horizontal displacement 20 meter. These two angles produced the horizontal displacement 20 meter, which are 30 and 60 degrees. So it's a 30 and 60 degrees. Mm, so just put 30 and 60 there, it'll be fine. And calculate the initial horizontal component of the velocity of the golf ball when it was projected at an angle of horizontal component of the velocity at 20, 20 degree. Remember the initial velocity is 15. So the horizontal velocity equals the initial velocity equal the velocity, okay, times the cosine theta. And then put the numbers in white is cosine theta because like if we decompose this velocity into the horizontal and the vertical direction, and you can see theta is here. You can see like this side is the horizontal component is v cosine theta. So put the numbers in v is 15, theta is 20, and we should have the result. The result should be a little bit smaller than 15 from this graph you can see. Yeah. Oh, so it's fairly close. Cosine 20 probably is 0.9 something. Yeah. Okay, the result of that will give us the value. Let me find out what cosine 20 is by using a calculator. Cosine. Yeah, I can't find it. Uh, I use uh, I use Google to find cosine 20 degree. 0.93, like 0.94. Yeah. So it's like 15 times 0.94. Mm, Next question, identify the trend between the projected angle theta and horizontal displacement SH of the golf ball. The trend between the projectile angle theta as theta increases from 10 to 40 degrees, the horizontal displacement increases. As the theta decreases from 50 to 80 degrees, the horizontal displacement decreases. Yeah. That's a trend. It's one mark. Infer which projected angle which would result in the largest horizontal displacement. Give a reason for your response. Because the result is symmetric with respect to theta equals 45 degree, and therefore theta equals 45 degree would give it the maximum displacement. Yeah, that's the answer for question 8. And for data set 3 is this is set up for data set 3. Let's read the question. A student set up the apparatus shown in Fig 2 to conduct an experiment to investigate the force acting on a conductor in a magnetic field. The student varied the current through the conductor and measured the time for mass reading on the mass balance. The data was processed and plotted in graph 2. The effective length of the wire in the magnetic field was 2 cm. The wire was oriented 90 degrees to the magnetic field. Let's see. This is the data they obtained. The current is the horizontal axis is the current, vertical axis is the force, and they obtained three lines. First one, identify the relation between the force acting on the conductor and the current passing through the conductor, including uncertainty of the gradient and the y-intercepts. So for this one, we need to look at the three questions there. It's a mathematical relationship. It's like a linear relationship, right? Between the force acting on the conductor and the current passing through the conductor. So the force acting on the conductor and current, so F equals M times I, like here, M times M X, Y equals M times I and minus something. Yeah, we need to write out the we need to give the uncertainty for gradients and y-intercepts. So what are the we still use the same that we given before. The uncertainty equals the maximum minus the minimum divided by 2. So the maximum would be 2.3 for the gradient. The maximum is 3. The minimum is 2.5. So the uncertainty there would be 0.25, and the uncertainty for the gradients would for the y-intercepts is 0.006 minus 0.002 divided by 2. It would be 0.004 and divided by 2, and the result will be 0.002. So let's write them down. So, uncertainty of what's it? Uncertainty, let's say n gradient. The uncertainty of the gradient. Uncertainty of the gradient is gradient is 3 minus 151 over 2. 3 minus 2.51 over 2. It equals 0.25. And similarly, we can write out the gradient because I can't move what I written down there, so I have to write it above. The uncertainty of the y-intercept is what is the gradient? What is the uncertainty of y-intercept? The maximum value is 0.06 minus the minimum one 0.02 divided by 2, and which gives us the value 0.002. Okay, and then lastly, mathematical relationship between the force and conductor. So the F equals, what's the average one? 2.7? Yeah, this is 2.70 plus minus, I think it's a 2.70, yeah, right? Yeah, it's 2.70 plus minus uh, 0.25 and times pi I, and then minus oh 0.02. Okay, this is the formula. Now let's look at the last question. Question 10. So concluding that quantifies the magnitude of the magnetic field through which the Y is passing, including absolute and or percentage uncertainty of the value that you determine, show your observation. And quantify the magnitude of the magnetic field through which the Y is passing. Quantify the magnitude. Uh, so then what do they want us to do? They want us to define B, quantify magnetic field, by using F and L. What does B equals? We have a formula which is F equals L and I cross B, and I cross B. And this is a vector formula. It tells us the direction of the force. Actually, it would say the I is it should be L cross B. I is a scalar. How can I cross B? It's a L. L is in direction of I. Okay, then let's write it out. Let's say it's a I L cross B. Remember, L is in the direction of the current, so it's kind of like a. And that's the reason why I wrote I L cross B at the first place. Mm, L and B's are vectors, so F is vectors as well. In terms of quantity, like in terms of their magnitudes, it equals um, B I L sine theta. So here they ask us to quantify. So it certainly refers to the magnitude of B. So here, to find out the magnitude of B, we can rewrite this formula. We know L and sine theta. L is 0.02. The length of the Y between the magnitudes, and theta is 90 degrees. So we should use this formula to quantify B. And what we need to do is just find out. We can rearrange the formula to have B equals F. And in high school textbook, it's not very rigorous about this magnitude sign. So we don't have to be very rigorous here either. It's like I, L, sine theta. We know L and sine theta. What we need to find is F over I. And here, the very important concept is that F divided by I, they are kind of referring to the change of F and the change of I. It's like, yeah. So if we think it is change of F, of change in I, and gives times L sine theta. And in this formula, that F over that I would be the gradients that we found earlier. The M, the gradient that we found from question 3, and times would be M over L sine theta. Mm, and we have found the M, which is including the epsilon and the values. Have we found the M we have found earlier is gradient uncertainty is 2.7 0 plus minus 0.25. Remember the M that we found earlier. And therefore here we can substitute this M in. So here 2.70 plus minus 0.25 and L is 0.02 and sine theta is 1. So the results would be 0. Divided by 0.2 is the same as times 50. So 2.7 times 100 is 270. 270 divided by 2 is 135. And 0.25 times 50 equals 0.25 times 50. 0.25 is a quarter. A quarter times 50 equals 50 divided by 4. 50 divided by 4. 40 divided by 4 is 10. 10 divided by 4 is 10 divided by 4 is 2.5. So it's 12.5. If we run it, that's my 12.5. If we run it, we come back to this one, 13. And what's the unit? Remember the unit? Tesla. So lastly, you say answer the question, just say the magnitude, just say therefore the magnitude of the magnitude of magnetic field through which the Y is passing is 135 plus minus 13.